One more important concept that we will use in forecasting, especially when we are using the regression analysis technique, is the concept called correlation. So correlation measures the strength and direction of relationship between two numerical variables. So it's a linear association between the two variables. Yeah? And the number is always between -1 and +1. So the sign of the correlation coefficient, whether it is minus or plus, that determines the direction. If you have plus correlation, so there is a positive correlation. When x increases, y also will tend to increase. Whereas minus correlations will be the opposite way. Okay, when x goes up, y will go down. Okay. So the sign represents the direction of relationship, and the absolute value represents how strong the relationship is. So the closer the R value is to +1 or -1, okay, that would represent very strong correlation. Whereas a number that is closer to 0 towards the center, that would mean not very strong, weak correlation between the two variables. Now this is the formula that we will use to compute the correlation coefficient. The numerator here is called covariance between x and y, the two random variables. And then we have square root of this times square root of this, which is really standard deviation of x, and then this is standard deviation of y. Now let's compute all of this in Excel. So we are trying to see whether there is correlation between the time and y. So again, find the average of x and average of y. Okay. Then we will do x minus x bar. So x minus x bar should always come from B37, so we have to make that absolute reference. Okay. And then y minus y bar. So here y minus y bar, and y bar should be absolute referenced. Okay. Then you take the x minus x bar and square it. Take y minus, then take the y minus y bar and square that. And then we go x minus x bar times y minus y bar. Copy all of that. Okay. And then let's put the bottom border back. And now we want the sum of these three columns. So let's sum that, and we'll go like that. Okay. Now variance of x is, okay, we need to divide this sum by count minus 1. So we go that divided by count of that minus 1 and end parenthesis. Okay. Or we can use variance function also. Yeah, I'll use the variance function for y, yeah, which will also be the same as taking that and dividing by 6. Now the covariance between x and y okay, so that would be this sum divided by count minus 1. Okay, so that is our covariance between x and y. If you take a square root of the two variances, that will give us the standard deviation of x and y. So now R is covariance divided by the product of the two standard deviations. Okay, you've already taken the square root, so we don't need to take a square root again. If we use these two numbers, then yes, we have to take a square root of that. Okay, let's format these. Now, of course, Excel has a function called CORR. Okay, Excel has a function called CORREL. So that's correlation. So you give the first range of values and then the second range of values. It doesn't matter which order. Okay, that function will give us the correlation. So you don't have to go through all of these computations. You can instead compute the correlation using the CORREL function in Excel.